Okay, hello everybody. In this video, we're going to be picking up where we left off with the June 2023 Algebra 2 Regents exam, which was question number 13. So I'm just going to scroll down to where we left off and pick up right here. So it's a little bit of a lengthy explanation for this question because I'm going to show you a few different ways to do it. So once again, the directions say which expression is equivalent to blah. So it doesn't say specifically what to do, which means you have to look at your answers to try to figure out what we're supposed to do. So the answers are all written in what we call quotient remainder form, right? When you have quotient remainder form, the quotient is written first plus the remainder over what you're dividing by. And notice we're dividing by 2x plus 4, and they all have that down here. So because it's in quotient remainder form, you have to think about what math we have done in the past that would put something in quotient remainder form, and that math is long division. So long division is the long way of doing this question. I am going to review it with you, and then we'll go over a couple of shortcuts. So to do long division, the way you want to set this up is with your long division symbol. You put the 2x plus 4 on the outside, 2x to the third plus 2x minus 7 underneath. Now, before I even start, what I'm noticing is the part that's underneath is missing a term. You always want it to be like that highest to lowest exponent where there is nothing missing. So I don't have an x squared term. What you want to do in place of the x squared spot is put that placeholder. It's a 0x squared, so it doesn't change anything. It just helps everything line up because long division is a very lined up process. So I'm just going to put that 0 in there. Again, it doesn't change anything. It just has that x squared placeholder, which you'll see in a second why that's helpful. So the process for long division. You need to figure out what I have to put up here so that when I multiply it by this 2x, I get exactly 2x to the third. So I'm not going to multiply that 2 by anything because I already have a 2. It's just going to be a 1 or nothing. But I do have to multiply the x by an x squared to get an x to the third. So now I'm actually going to multiply this through. X squared times 2x gets me a 2x to the third. And I have to multiply it by this 4. 4 times x squared will get me a plus 4x squared. Now, when you're doing long division, you then have to subtract that row. It's just part of the process. So you're going to subtract this and this. So the rule is to always change the sign. That's how you're going to get that subtraction in there. These should always cancel. That's the goal. When I made it the exact number, then I subtracted it and made it cancel. So now when I add my x squareds together, I get a negative 4x squared. And again, that's why I wanted this placeholder here so that I can just line these up like so. And then your next step is to bring down the next term and then start the process all over again. So now I need to figure out what I need to put up here so that when I multiply it by 2x, I get a negative 4x squared. So if I'm multiplying by a positive 2 and I need to get a negative 4, that's going to have to be a negative 2 up here. And then I'm going to have to multiply the x by an x to get that x squared. So now I multiply it out. Negative 2 times 2 is a negative 4x squared, which is exactly what I wanted to happen. And then negative 2x times 4 is a negative 8x. But again, I am subtracting this whole row. So if I'm subtracting that row, I'm going to have to change those signs. They're already minuses, so it's like minus a negative, which turns into a positive. Now the goal was to get these to cancel, and they do. And then 2x plus 8x is going to get me 10x. Now I'm going to rinse and repeat, do the same process again, bringing down that negative 7. Now since there's no other term after the negative 7, that tells me that this is going to be my final round. So I need to figure out what needs to go up here so that when I multiply it by 2x, I get 10x. So now I don't have to multiply the x by anything because it's already an x, but I do have to multiply the 2 by a 5 to get that 10x. So I will put that 10x down here, and then 5 times 4, because I have to distribute it through to that as well, gets me a positive 20, but then again, I remember I have to subtract this row. When I subtract, these cancel. That's the goal. See how it happened in every line? And then negative 7 minus 20 is a negative 27. Okay. Now, if this was a part 2, to write your answer in a quotient remainder form, you'd have to write this up top first. So your answer would be x squared minus 2x plus 5. Then you add the remainder, which was negative 27, over what you were dividing by, which is 2x plus 4. So that's my answer. I see my answer right here. It is choice 1. Now, if you forgot how to do long division, or if you just wanted to work smarter, not harder, there is another way to do this question. So back when we were learning long division in class, we talked about something called the remainder theorem. Look at all 4 answers. All 4 answers have a different remainder. So instead of doing the full long division, I could do what we call the remainder theorem, And it's kind of like a little shortcut to getting to the answer. But you have to remember the remainder theorem. It's very helpful. So for the remainder theorem, you have to plug in what you get when you set the denominator equal to 0. So I'm going to do 2x plus 4 equals 0. So I'd subtract the 4 over, divide by 2, and I get x equals -2. So that tells me I have to take that -2 and plug it into the top of my expression. So everywhere I see an x, I'm going to put a -2. So my expression is 2x to the third. I'm going to do 2 times -2 to the third plus 2x, so plus 2 times -2 minus 7. So when I type that in, I get the remainder, which was -27. So just by doing that quick remainder theorem, I find the remainder was -27, and this was the only answer with a remainder of -27. So it would have to be choice 1. So it could have skipped all of this, or let's say you even try long division and you're like, oh, it's just not working. Maybe you miss a sign. We all make mistakes. These things happen. You should have another method in your back pocket. Okay, I do want to remind you about the remainder theorem as well. If you do the remainder theorem and you get an answer of 0, that means that what you're dividing by is a factor. That's a huge thing that comes up on the exam a lot. So if you have a remainder of 0, it means that what you were dividing by went in equally without a remainder, hence it is a factor. So sometimes the question is just asking, is blah a factor of blah? And that's another way that you can answer that without factoring it. Okay, that was 2 different methods. What I'm going to show you is actually the shortcut I taught you in the first video for this exam. If you're just joining, I'm going to explain it like it's the first time in case you missed it. I'm just going to kind of clear some of this up. We're good. Okay, so the keywords in this question for the shortcut are equivalent to. When you have something like equals, equivalent to, same as, whatever, what you can do is plug a number, I always use 2, into the original expression, and then plug that 2 into all of the other answers as well, and see which one gets an equivalent output. So in your calculator, what you can do to easily plug it in is 2 stow x, enter. So 2 stow x, enter. What that means is every time you plug in an x now, it's going to plug in a 2 for you. So like if I say 9x, that'd be 9 times 2, which is 18. So I'm going to now plug in my original expression. If you have the 83 calculator, make sure you're putting parentheses on top, parentheses on bottom. If you have the 84, hit your alpha y equals enter or alpha x, and it'll get you the fraction format. So I'm just going to type it in exactly as I see it because I already did my 2 stow x. So plus 2x minus 7 over 2x plus 4. Now when I type that in, I get 1.625. That number doesn't mean anything at all. What we're going to do is plug in the choices and see which one also gets me 1.625. So spoiler alert, we already know the answer is choice 1. So when I plug in choice 1 right now, we'll see that it also gets that same decimal. Oop, oh man, wow, whoa, 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 I messed that up. Minus 27 over, there we go, 2x plus 4. And I do, when I type it in correctly, get the exact same number. I'm just going to plug in one more so you can see how it wouldn't be equivalent to if it's the wrong answer. Maybe I'll plug it in right this time. 2x plus 4. Boom. When I plugged in choice 2, I got 2.625. So see how this, the original was equivalent to choice 1, but it is not equivalent to choice 2. If you plug in choices 3 and 4 as well, those also don't work. So this is a really good thing to do in a pinch. It's also really good to use for a part 2 question. Let's say this wasn't multiple choice. You guys would have been given this, and you would have gotten this as your answer. You can still do 2 stow x, enter, plug in the original, and then plug in your answer and make sure you get equivalent values. It's an awesome way to check your answer. All right, number 14 is a little lengthy, especially for a multiple choice question, but here we go. So it says a popular celebrity tracks the number of people in thousands who have followed her on social media since January 1st, 2015. A summary of the data she recorded is shown in the table below. So it gives me an X and a Y column. X is going to be the number of months. Y is going to be the number of social media followers. And remember, this is in thousands, so it's not like 3 people here. After 2 months, she had 3.1 thousand followers. After 11 months, she had 7.5 thousand followers, and so on. So that's how I'm going to read the table. After that, it says the celebrity uses an exponential regression equation. I love when they specifically tell you exactly what to do. We'll do that in a second. It says to model the data according to the model, about how many followers did she have on June 1st, 2018. So we can't answer that second part until we find the regression equation. So if you remember how to do regression, go for it. If you need the explanation, here we are. So the first button you're going to press to do a regression is stat. I have it highlighted in my calculator right now. It's like in the top middle. Then you have to press edit. So when you press stat edit, you will probably likely already have numbers in here. If you're already cleared out, great. If not, to clear them out, you have to scroll all the way up to L1 and L2, press clear enter. So clear enter, highlight over L1 or L2 again, hit clear enter. Do not hit delete. That will delete the list and you'll have to reset your calculator to get the list back. So I already have my numbers typed in. You guys take a second to pause the video and type them in. I do want to remind you that you are giving the information to your calculator so it can do the math for you for the regression. If you type in the numbers incorrectly, it can't do the math correctly. So please make sure your numbers are typed in correctly. And then your next step is to press stat again. You are going to go over to calc. And then remember, it's telling you what to do. We're doing exponential regression. So you're going to scroll down to the choice that says exp. Reg. It abbreviates it for you. So exponential regression, you should have L1 in your X list, L2 in your Y list, no frequency list, just press enter. So I know it's multiple choice and the work is kind of whatever, but I'm going to show you the work that you would need to show if this was a part 2, 3, or 4. So I always tell my students you need to copy down YAB, Y equals, A equals, and B equals. It also doesn't tell me what to round to, so just for good measure, I'm going to use most of these decimals. I didn't copy the whole thing, I just did a good majority of it. Okay, so that is the work that you would have to show if this was a part 2, 3, or 4. I just wrote it out to show you what we need to do next. So A is this number. That means in your equation format up top, I'm going to plug that number in for A. This number is B. I'm going to have to go up here and plug it in for B. So your equation is going to end up being Y equals, I'm plugging in this A number for A, times B, which is this number, and that is raised to the X. So that is my equation. That was kind of like the part A to this question. Now it says using that model, so using that equation, how many followers did she have on June 1st, 2018? So this part is tricky. I'm going to be totally honest with you guys. I'm really bad at like adding months together. Like I know I'm a math teacher, I should be good at it. I don't know why, I just struggle. So if I pause for a second, it's because I'm doing some math on my fingers. Don't judge me. Okay, so the X variable is the number of months since January 2015. So I'm going to try to speed run this a little bit. And I'm going to take some notes off to the side so I don't lose track because I'm trying to talk and do some tough math for myself. So the number of months since January 2015, and we have to go all the way up to June 2018. So I'm going to do this by year first. If I'm jumping to January 2016, that would be 12 months after, right? Because there's 12 months in a year. Now we're still far. So I'm going to go up to January 2017 now. That would be another 12 months, which would put me at 24 months since January 2015. And I still have to go a whole nother year. So I'm going to go to January 2018 by adding another 12 months. That'll put me at 36. Now here's the tricky part of this question. We are going to June 1st, 2018. So I can't count June as a month. So after January 2018 being 36, we have February, March, April, May, and then I can't count June. Wait, did I skip one? February, March, April, May. See, I knew I was going to have a hard time with this. So after January would be February, which would put me at 37. Why is this so hard for me? I'm sorry if it's easy for you and I'm like slowing you guys down. Skip ahead if you are over this part. So February, March, April would be 39. May would be 40. And then until June. Sorry, we do need to put June on here. June would be 41. So the number of months since January 2015 put me at 36. And then when I added the months, I truthfully would have done this on my fingers. It's just really hard to talk out loud and count on your fingers. Just, you know, some things that we struggle with as math teacher over here. It puts me at 41 months. So what we have to do is rewrite this equation, 1.767957 times still 1.1848316, but X is going to be 41 months. So now I'm going to type that into my calculator. And again, I didn't round. Usually on a part 2 question, it would tell you like round to the nearest 10th or 100th or whatever. Just for accuracy, I kept this whole decimal to the 41. So this is the answer that I get. So hang tight for a second because I know the answer is not on the multiple choice. We'll talk about it in a second, but this is the number that I got, blah, blah, blah. Now you have to remember that your y variable is in thousands. So if this is in thousands, I'm going to have to kind of like multiply it in thousands if it seems like accurate to do that in your calculator. But if you look at the answers, it's pretty self-explanatory. It's gotta be choice 3. It's the only one that has that 1850. But to put it in terms of thousands, you're going to have to move that decimal point over 3 spots. So when I put it over 3 spots, it is rounded, but it does say in the directions about how many followers did she have. Like we are really accurate over here with our 1850,944.797. The answer does not have that, but if you look, it just kind of changed those 2 zeros, which is why it said about how many. So I guess I probably could have rounded since it did say about, but you know, just to be careful, I used the whole decimal. So quite a long question. So you had to do the regression to come up with the problem first, or to come up with the equation first, and then plug the answer in. So a little bit tricky. I was just looking to see if there was like a way on the table to do it instead. I think that was the only way to do it. All right, so number 15. Luminescence is the emission of light that is not caused by heat. I can't tell you how many people came up to me after they took this exam and they were like, what is that luminescence question? Sometimes they give you information that's not helpful to the question. You can totally ignore that idea. It says a luminescent substance decays according to the function below. That's what you care about. This function and that it gave you the word decays. That's all we've really talked about in class. Now it says this function can be best approximated by. So if you look at the answers, they're all written kind of in a different format, but they have very similar ideas. Like these two both have that IO with the E that this one also has. These ones don't have the E anymore, and some of the exponents are different. We're basically finding which of the choices is going to be equivalent to that original expression because it's asking which choice can be best approximated by. So what I first noticed is the answer to choice 3, which is usually how these answers go. If this is more than, if you've done more exams than this one, you kind of notice this pattern. Usually you have to write it without an exponent at all and just having that T up there. So that's the answer that I checked first. Now notice in this problem, there is no E here. So to make these match up, you would have to do E raised to that number, not the T. So in your calculator, you would do E to the -1 over 0.6. So to get an E, you have to press second divide, raise that to the -1 divided by 0.6. I ignored the T completely. Oh, I forgot the 3. Oops. I'm so sorry. I missed the 3 completely. See that 3 out there? You were probably like, what is she doing? That 3 should also be there. So this is technically to the -3 over 0.6. Or if you didn't recognize it that way, you can raise it to the E to the 3 times -1 over 0.6. I just totally missed that. So I'm going to put that in here like so. That's a lot better. Whew. So when I raise it to the 3 times -1 over 0.6, I get that number over there on my calculator, which is this number. So when I've raised it to all of those numbers, that means the E is gone, all those numbers are gone. And when I take those away from the original expression, I have IO, the E is gone, the 3 is gone. It's just raised to the T, but it's that number raised to the T. So I'm going to put that 0.0067, blah, 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 to the T, which does match up with choice 3. If you wanted to see if the other ones are equivalent, you can plug them in. So look at choice 1. So if you didn't recognize what I recognized right away with choice 3, that's okay. You can check all of the answers. I'm also going to teach you a shortcut in just a second. But see how for choice 1, it still has that E. That means that we're not going to type in the E. We're just comparing the exponents. For them to be equivalent, these exponents should equal each other. So there's still the T there, but the numbers have been simplified. So what you have to do is just multiply the exponents 3 times. This would be -1 over 0.6. And when you multiply those together, you were supposed to get this if it was equivalent. 3 times -1 over 0.06 gets you -5. This does not have a -5 in it. It is not choice 1. And you're going to kind of do that for all of them. This one has a 5, and wow, is that close, but it needs to be a -5, because if you look at my calculator right now, when you multiply the 3 by that -1 over 0.6, you get a -5. So choice 2 is close with that 5, but not quite there. And then for this one, notice the E is gone, but it's raised to the 0.06 still. So the only way to really do this one is to plug this into your calculator and see if you get that number. So I do 0.0497 to the 0.6, and I did not get this number. That's the number I should have gotten if it was just raised to the T, and I didn't. So that it's kind of like working with your answers and what you have, plugging stuff in to see if they're equivalent. I know it's kind of tricky, which is why I'm going to show you the shortcut. It's the same, even though it doesn't use the words equivalent to, it's saying which equation can be approximated using that, this function can be best approximated by. So if this has to be approximated by something else, of course they're going to have to be equal to each other. So here's where I would do that 2 stow x enter. Again, I already am set up like that, but if this was the first one you were doing, you would hit those buttons, 2 stow x enter. And then this one's a little tricky, but again, you're kind of like using your resources, using what you have. There's a couple different variables in this. So the T is what I'm going to use for X. So everywhere I see a T in my calculator, I'm going to plug in an X instead, just like you would if you were graphing these. But the problem with these ones is there's another variable with that I sub 0. That's always going to be your starting amount. You can make up any number you want as long as you're consistent with all of your answers. Sorry, it's fine. So for I0, I'm going to use 20. Okay, I've totally made up 20. There's nothing significant about it, but I'm going to replace all of my I0s with 20 to see which one ends up being approximated by or equivalent to, like as close as it's going to get. It might not be exact because it's saying approximate, but let's find out. So I'm going to plug in the original expression now with my 20, the E. It is raised to the, I'm not going to forget the 3 this time, 3 times negative x over 0.6. Make sure I didn't forget anything. Okay. And again, there's nothing significant about this number other than you're trying to find the answer that matches it. So ugly number, doesn't matter. Let's plug in choice 1. We know choice 1 is wrong, but let's just plug it into C. I have -1. Oh boy. -1 over, there we go, 0.18. I don't know what is so hard about me plugging this one in. It's just yucky. So I get 0.077, which is not equivalent right away, so that one's out. I plug in choice 2, 20 e to the 5x. Oh my gosh, the last one I didn't plug in an x. I knew I did something wrong. So 20 e to the 5x, this one is 440529.315896. Forgive me, I've been recording a lot of these videos recently. So the first one, it's still not going to be equivalent, but I did plug it in wrong. That was supposed to have an x, so I'm just going to type it in again. My bad. Still not the same. Blah, 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 still wrong. Okay, but make sure you're typing it in exactly as you see it. This one's kind of hard because sometimes you're plugging in the X, and then I showed you the first time doing it without the X. I love plugging it in with the X. I think it's actually easier, but to each their own, okay? So choice 3 we know is correct. Let's just double check that it matches, and I'm going to plug it into the X. And look at that. I got 0.008978. And then that last one, 0.0497 to the 0.6x. I got 0.027266. So this process is not perfect, especially when it says approximated. Approximated means you're probably not going to get that equivalent to exact answer. But if you look at your choices, there's one that's definitely closer than the others. I have 0.0009. This one's 0.0002. This one is 440,000. Like clearly that one's wrong. 0.027, this one's 0.0089. That 9 would bump that 8 up. It's so close. It has to be this one to be the best approximated answer. Again, when it's not equivalent to, it might not be the exact answer, but it's still a good method to use. Okay, so the moral of that question story is just kind of use your answers to your advantage. Plug in when it says approximated, same, whatever, equal to. All right, let's jump to number 16. This one's much easier than the last couple. Here we go. It says the heights of the students at Central High School can be modeled by a normal distribution. Normal distribution means normal CDF. We'll talk about it in a second. But it says with a mean of 68.1 and a standard deviation of 3.4. According to this model, approximately what percent of the students would have a height less than 60 inches or greater than 75 inches? Ooh, this one is tricky. Okay, so we're going to have to find both of the probabilities first using, like I said, that normal CDF. So there's two different things it's asking me to find here. First, the percent that have a height less than 60 inches or greater than 75 inches. So I have to find two different ones. So first, for normal CDF, remember the layout for normal CDF. Norm CDF, you have to type in the minimum, then the maximum, then the mean, then the standard deviation. Sometimes your calculator lays it out for you. It just depends what model you have. But either way, to get to normal CDF, you have to press second vars. So I'm going to press second vars and go down to normal CDF, never normal PDF. So for the first one, which I highlighted or underlined in red, it's less than 60 inches. So if I'm talking about being less than 60, there really is no minimum. It's just anything smaller than 60. So the way we talked about this in class is if there's no minimum, use just the smallest number you can come up with. I do negative and I button mash the heck out of that 9. So negative 99999 is my minimum. 60 would be my maximum because it's everything less than 60, so that has to be the highest. And then the mean and the standard deviation were given in the beginning. It is 68.1. And the standard deviation is 3.4. So when I type all of that in, negative 60, comma goes between them. By the way, the comma is next to the left parentheses. So as you're typing it in, make sure you hit that comma between all of your numbers. And 3.4. Okay, so that was my first probability for this question. It was 0.008601206. And again, like I said, that was the first one for being less than 60. Now I need to find the probability of being greater than 75. So I'm still going to use that same norm CDF. So I hit second vars, normal CDF. Remember, CDF is cool, C. I know it's lame, whatever. But now I need my new minimum. For this one, it's greater than 75. If you have to be bigger than 75, that means that 75 is the smallest it can be, and it can go up until that biggest number you can type in. So button mash that 9, and then same mean and same standard deviation. So I'm going to type that in. You type it in as well. Make sure you practice with all of these buttons. Hit that comma. And I'm just going to copy that number down. Okay, so now that I have the two probabilities, and again, if you need a minute, just take a minute, pause, and keep plugging that in. It's really important that you know how to type those in. Okay, so when I have the probability of or, we have talked about this in the probability unit. I'm just going to bring you back to that Venn diagram idea. Probability of or means it's the probability of like both things happening. Think about in class with like the real life examples we talked about, like the probability of being female or a junior. You have to count the females and the juniors together because the probability of being one or the other adds like the total odds together. So in terms of like a Venn diagram, it was everything in this circle added together with everything in this circle. Now in the OR formula, we did have to subtract the overlap, but for this one, there is no overlap because we're talking about less than 60 and greater than 75. And I don't know about you, but I'm pretty sure it's impossible to be less than 60 inches and greater than 75. So there's going to be nobody in this center. So all I have to do to find the OR is add my two probabilities together. So I'm going to be adding together this number and this number. So I'm going to go to my calculator, add those two numbers together, and I get an answer of 0.029809. That's a great answer. And if it said, what is the like proportion or what is the probability, I could leave my answer like that, but notice my answers are percentages. To get a percent, you have to scoot that decimal to the right. So I'm going to scoot it 1, 2, and my decimal is going to be here. So it's 2.98, blah, blah, blah. And that percentage is going to be choice 4. You're probably noticing, and I'm sure you've noticed if you've done a lot of exams, but the first 12 questions are usually easier than the second 12 questions. There's a lot of details in all these questions we've done so far. We're only on question 16 and we started at 12, so we've got a long way to go. Let's just keep going. This next one's a little easier though. You just need to know the idea of standard deviation in terms of this normal distribution. So lots of words, here we go. Marissa and Sydney are trying to determine if there is enough interest in their school to put on a senior musical. They randomly, which is good, remember randomly is good, surveyed 100 members of the senior class, and 43% of them said they would be interested in being in a senior musical. Marissa and Sydney then conducted a simulation of 500 more surveys, each of 100 seniors, assuming that 43% of the senior class would be interested in being in the musical. The output of the simulation is shown below. So the best way I can explain a simulation to you is it's kind of like another fake study was given. And this one was a simulation of 500. So it's as though they gave this, sorry, something in my classroom just made a noise. It kind of startled me. I apologize, getting back on track. A simulation, I'm sorry, I totally spaced and forgot where I left off. That kind of startled me. So the simulation is like pretending they kind of gave that survey 500 more times. So Marissa and Sydney gave this computer simulator the data that they got from their one survey, and the computer pretended they gave that survey 500 more times and analyzed some possible results that could have happened. So it's all hypothetical, but it's all also very possible, very realistic. Like if they gave the survey one more time, maybe instead of 43%, it was 42% and so on, okay? The only other difference that I want to point out is the x-axis here is in proportion. So like 0.44 means 44%. So 43% is kind of like right in the middle here, okay? Like 0.43. All right, the question says the standard deviation of the simulation is closest to. So what you guys have to remember about this normal distribution is 95% of your data, like that middle 95 is 2 standard deviations out. So just to kind of draw you a quick picture, this is your mean. If you don't know the symbol for mean, it's X bar. When you go 2 standard deviations to the left and 2 standard deviations to the right, this will contain a majority of your data. And we always called it the middle 95% because there's usually going to be some data outside of that middle 95. So I'm just going to sketch a little like box in right now. It's total estimation, but I'm boxing in about 95% of those data points. It's not perfect by any means, but that's about where that middle 95% is because all these extra dots out here are going to make up that remaining 5% to get 100% of your data. Okay, but that box that I boxed in is about that middle 95. Now, to get to that middle 95 that I boxed in, we had to go from the mean, which is in the middle, out to standard deviations. It's just the definition of of the middle 95% is you go out 2 standard deviations. So now if the mean is about right here in the middle, kind of about at that 0.43, I need to go out 2 standard deviations in each direction. So I'm just going to kind of split it into pieces. This would be 1 standard deviation, 2 standard deviations. This way, same idea. I'm just estimating. Your lines don't have to be perfect with mine. I'm just kind of splitting it up. So that means that 1 standard deviation went from about 0.44 to 0.48. So if I look at my choices, again, this is about, but to get from 0.44 to 0.48, I would have to go up 0.04. And the answer that is closest to that is choice 2, which is 0.05. Okay, there is no perfect answer to this, but the other answers are way too far away. If I went only over 0.02 from the middle, whoops, I keep going to erase and I don't erase. 0.02 from the middle will put me at 0.046, and this is definitely not 1 standard deviation. This red line right here is not 1 because that would make this 2 standard deviations, and that's not 95% of the data. Okay, 0.9, if you go 0.9 from 0.44, You're going to be way too far out. It's going to be closer to this end. And that's not 1 standard deviation. That would mean this is 2, and there's no dots over here. So you have to split that up into your 2 standard deviations in each direction, where this is your average, and then you go out 2 in each direction. Okay. All right, number 18, also kind of a tricky question, bear with me. So it says, for f of x equals the cosine of x, which statement is true? So they're talking about even and odd functions, so let's review what those actually mean. For an even function, the definition of even function is that opposite inputs give equal outputs. And the definition of odd is still opposite inputs. Even and odd are both talking about opposite inputs, but for odd, they give opposite outputs. And then remembering that inputs is x, outputs is y. So the way that I had you guys memorize this in class is even, equal, odd, opposite, and they're always opposite inputs. So what I'm looking at in terms of inputs and outputs is your table. So on a table, what I mean by opposite inputs is like -2 and 2. For example, you could look at -3 and 3, -4 and 4, -1 and 1. I don't care. You just have to look at opposite inputs and look at their outputs. Now it's just saying which statement is true, so we're going to have to check all of them. So in your calculator, when you are graphing trig functions, you have to be in radian mode. So go to your mode button next to second. Make sure you're highlighted over radian. If you are not, change it really quick before we continue with this question. And then hit second mode to get out of that. And now I'm going to hit my y equals to graph this. Okay, so it says f of x is cosine of x. So everywhere I see an f of x in all of these directions, I'm going to want to plug in cosine of x. So this one is going to be 2 times cosine of x. So I'm going to type that in first, 2 cos x. And then I'm going to look at my table because I want to look at those opposite inputs. Okay, so my opposite inputs, for example, like -2 and 2, -1 and 1, -3 and 3, it doesn't matter which ones you look at, just compare them. -2 for this first one that I graphed has an output of -0.832. And then +2, when I go down to it, has an output of, guess what, -0.832. Those two numbers are equal. If they have equal outputs, they are even, and this one says that they're even. So that one checks out, but it's not only talking about that, it's talking about another one as well. So I'm going to have to graph that one too. Now this one's a little bit trickier to plug in, still not too bad. It's telling you to do f of 2x. So that means that everywhere you see an x in your f of x function, you're going to have to plug in a 2x. So this equation, that f of 2x, is going to be the cosine of, again, everywhere you see an x, you replace it with a 2x. So it's going to be the cosine of 2x. And then I am again going to hit second graph and compare my outputs for opposite inputs. So again, you're looking at your -2 and 2, your -1 and 1. My -2 for this one is -0.653. My +2 is, guess what, -653. Those are equal, and equal outputs means it's even. So it's kind of looking like our answer is choice 1, but if this was your exam, you should always check every answer, but I'm liking choice 1. I'm going to circle it for now and then continue to check. So choice 2 says f of 2x. Guess what? We just did that one. I'm looking at that table on my calculator right now, and we already figured out that it was even. Choice 2 is saying that it's odd. Whew, that one can go right away, so not a lot of work with that one. Okay, choice 2 says they're also odd. If you look, 2 of f of x, we already did, and we said it was even. This one's saying that it's odd. Goodbye, not choice 3 either. Okay, now the next, or the choice 4, we didn't look at all yet, so we're going to have to actually investigate that one. I know we know it's choice 1, but you have to check them all. So choice 4 says f of x plus 2. Remember, f of x is this, so it's telling me to do cosine of x plus 2. So I'm going to go to my y equals. I'm going to type that in, cosine of x plus 2, and I'm going to hit second graph. When I hit second graph, I'm looking at outputs for opposite inputs. So -2, my value is at 1.58. 2 is at 1.58. 1.58 and 1.58 are equal, which means that that is even. And guess what? It's saying it's odd. Goodbye. So it has to be choice 1. But see how we went through and checked? It didn't take too much time to go through and check. You just got to plug it in your calculator, and you do have to have these memorized, what even and odd functions are. It's really important. This question's kind of impossible without it. Okay, off we go. Number 19. Okay, 19. I love when they put this on a part 1. It's like a multiple choice question. It says the solution set of blah is. So when you guys are solving a fractional equation like this on a question that is a part 2, 3, 4, where you have to show all of your work, of course you would have to solve it. I will go through that process with you. But then the last step of solving this equation is to check. If you have to check anyway, just start by checking your answers. It's one of the shortcuts, and it works really well with this one. All you have to do is check. So I'm going to show you the work smarter, not harder way. Then I'll show you how to actually solve this the right way in case you would have to show your work for it. So when you have the solutions as your answers, you are going to do -6 stow x, enter, and type that into your equation. So I'm going to do -6 stow x, enter. And then I'm going to type it into my 83 calculator people, parentheses, around your fractions. Please, all of them, all of it. I know it's a lot of parentheses. I don't care. Do it anyway. So if I have the 83, I'm just going to type it in. Now with an x, remember, you don't have to type in the number. You still can if you want to do like -6 minus 5. You can do that instead. I like to use the stow because you just type in what you see. It's a lot easier. So I typed in the whole left side. And I got for choice 1, -1.227, blah, blah, blah. Okay, I want to see if that's equal to the right side. So I'm going to type in the right side of my equation. It's 6 plus 10x over x minus 5, x plus 2. Oops. Look at that. I got the exact same thing. That's great news. This keeps happening with this choice 1. I'm actually quite impressed. So because they're equal to each other, that does mean that -6 is an answer. But, like I said, you should always check all of your other answers. Because -6 is an answer, though, I can eliminate this, and I can eliminate this because they don't have a -6 in it. But see how this one does? So it's either going to be choices 1 or 3 right now. I have to check to see if 5 works. If it works, I'd pick choice 3. If it doesn't work, I'd pick choice 1. So now we're trying out 5. So I'm going to go over here and do 5 stow x, enter. 5 stow x, enter. And then you guys know the copy and paste, hopefully. I'm going to go up and just copy this. To copy, you just scroll up and highlight. So I'm going to do it again. Scroll up, highlight. And when you're highlighted over it, press enter, enter. Overflow. Okay, it's not actually an overflow. Yours will say error. I didn't even look ahead to that. It is not an overflow. Please ignore it saying that. It's just a calculator app glitch. Yours will say error, though. The reason it says error is because you are plugging in a 5 right here and right here. Look at where I wrote them. 5 here and here. 5 minus 5 is 0, and you are not allowed to have a 0 in the denominator of a fraction. That's a big no-no. So 5 gets rejected, which makes it choice 1. Okay, it's not an overflow. It's not too big. Don't listen to that word. There will be an error, though. When it shows up on your calculator as an error, that's a huge hint to you to check the denominator because it does not work in the domain. It is undefined. Okay, now that was a whole lot of checking, which you have to check anyway for a fractional equation. So since you had to check anyway, it was worth the time to just jump into the check, but here's how you solve it for real. So when you're solving a fractional equation, the rule is to multiply by the whole LCD, and your LCD takes a little bit of all of your denominators. So my first denominator is x minus 5, second one is x plus 2. So I have to take a little bit of all of them, but see how the last one has the x minus 5? I already have that. It has the x plus 2. I already have that. So you're not going to list them twice. You just take a little bit of everything so that everything in every denominator is accounted for. And it is. Now what I have to do with that is multiply all of my fractions by that LCD, the whole thing. So next to this one, I'm going to write x minus 5, x plus 2. Next to this one, x minus 5, x plus 2. And what you do to one side, you do to the other, x minus 5, x plus 2. Now, the reason we're multiplying by the LCD is to turn this into a no longer having fractions equation. And that's exactly what's going to happen. When I multiply this first one by x minus 5, I have an x minus 5 in the top and the bottom, and those cancel. The next one, I have the x plus 2 and x plus 2. Those are going to cancel. And on my third fraction, the x minus 5 cancels with the x minus 5, and the x plus 2's cancel as well. So notice what happened. No more denominators. They're completely gone. And now I can bring down everything that's left in the numerator to solve this equation. So my first fraction has both of these left over. I'm going to bring them both down, and I'm going to write it over here so I have some space. So it's x plus 3, x plus 2. The second fraction has a 6 and an x minus 5 with a plus sign as well. So I'm going to bring down that plus 6 times x minus 5. Then I'm going to bring down the equals, and then everything canceled in this one, so the original is just going to come down as 6 plus 10x. And now I just have a lot of multiplying and solving to do. So I'm going to double distribute this out. X times x is x squared. Again, I shortcut this with my students. So plus 2x plus 3x is plus 5x, and 3 times 2 is 6. I'm going to distribute this through. 6x minus 30 equals 6 plus 10x. Now, if you have an x squared and an x in your equation, you are going to have to get it equal to 0 so that you can factor. Every time there's an x squared and an x, the goal is factoring, and you have to be equal to 0 to do that. So I'm going to subtract the 6 and subtract the 10x, and I just have a lot of combining to do. So there's no other x squares other than this one, so I'm going to bring that down. When I'm combining my x's, I have a 5 minus 10 plus 6. That's just going to get me a plus x when I combine it all, technically plus 1. And then these 6's are going to cancel, so that minus 30 is just going to come down, equals 0. Now, to factor this, it is an easy trinomial, so my goal is to figure out what multiplies to negative 30 that adds to the middle number, which is a 1. So my numbers are going to be 5 and 6, and it's going to have to be 1 positive and 1 negative. To make it add to a positive 1, it's going to be positive 6 and negative 5. So my factors are going to be, x minus 5 and x plus 6. To which I will then tee it up, and I get x equals 5 and x equals negative 6. So here's what I was talking about where you have to check it anyway. You can't just pick choice 3 in a fractional equation. It's one of those times where you do get extraneous answers and you have to check. So at this point is where you would actually do your check. The fast, speedy check that I taught you guys in class is to just plug it in your denominator. If I plug a 5 into my denominator, we talked about this earlier, 5 minus 5 gets you a 0, and you can't have a 0 in the denominator, so that would cancel out that 5. It gets rejected, which means your only answer is going to be negative 6, which makes it choice 1 anyway. So that's how you would do all of the work if this was a part 2 question. It is often a part 2 question, so make sure you know how to do that. But yeah, that's kind of the spiel for that one. But you can always just check it if it's a multiple choice. All right, number 20, given x and y are positive, which expressions are equivalent to x to the third over y? So there's a few different ways to do this question, but the big one here is equivalent to. You can use that shortcut I showed you earlier. I will go over that after I go over it the right way. So the right way is doing a bunch of exponent rules for all of these. So for choice 1, or like Roman numeral 1, I should say, it's y over x to the third to the negative 1. When you have something raised to the negative, it means you have to take the reciprocal. So when I take the reciprocal, it's going to put that x to the third on top and that y on the bottom. Now it's technically raised to the positive 1, but anything raised to the positive 1 just stays the same. So this is what I get for choice, or Roman numeral 1. Now, Roman numeral 1, when I use that exponent rule, is equivalent to the original. So that means 1 is correct. So mark that in some way and look at your choices. The only one I can eliminate right now is choice 3 because 1 is not in the answer. All right, now I'm going to use exponent rules for Roman numeral 2. So when you have a radical, you're going to have to T-bow it. Remember, T-bow means top inside, bottom outside. So I have to rewrite it as a fractional exponent. The inside number goes on top, the outside number goes on the bottom, and that is times y to the negative 1. So same rule with that negative 1. I'm going to have to flip this to get rid of that negative exponent. Right now it's technically on the top because this is all over 1, so if I flip it, it will move it to the bottom. So on the bottom will be a y, technically to the positive 1, but I don't have to write that. And then on top, 9 divided by 3 is 3. And look, we got x to the third over y again. So this one is also correct. So I'm looking for one that has the 1 and the 2, which means choice 2 is out. So now I still have to check choice 3. Looks a little bit longer, but still not too bad, just using those exponent rules again. So I'm going to keep that x to the 6th times, I have to T-bow this, so it's going to be y to the fraction. Inside number goes on top, outside number goes on the bottom, and that is over. There's no math I can do down here. I'm just going to bring it down. I am also going to simplify that 8 over 4 to be a 2. Okay, because now I'm dividing. When you're dividing, you subtract your exponents and you keep with common variables. So x to the 6 divided by x to the third is going to be x to the 6 minus 3, which is 3. When I do that with the y's, it's 2 minus 3, which is going to get me a negative 1. I can't leave negative exponents, so I'm going to have to flip this just like I did for the last one. Technically, right now, it's all over a 1, so when I move that y to the bottom, keeping the x on top because the x is raised to a positive, I get x to the third over y, which is exactly what we started with. So all of these are actually equivalent, and it's going to be choice 4. Now, if you were like, I should have paid attention more during exponent rules because that was really hard, you can use the equivalent to shortcut. Now, the difference with this one versus the other ones that we've done is there's 2 variables. So you just have to keep it straight about which variables you're plugging in certain numbers for. So for this one, you need an x and a y. I'm going to use that x is 2 and y is 3. So when I plug in the original to my calculator, again, x is 2, y is 3. So it's going to be 2 to the third, 2 to the third over 3. Now again, there's no significance to this number. I tell you again, all it means is you have to find the one that's equivalent to that. So I'm looking for the choices that are equivalent to 2.6 repeating. Now choice 1, or Roman numeral 1, you know what I mean. Y is 3, so I'm going to put the 3 here. X is 2, so I'm going to put the 2 here. And I'm going to just type that into my calculator. So I have 3 over 2 to the third, and that's all raised to the negative 1. And look, I get the same decimal, 2.6 repeating, so that means that this one works. So again, we'll do that for all of them. It's kind of that same gist. I just want to make sure you guys know how to plug all of this in. So x is 2, y is 3. And again, those are hypothetical numbers. I just want to make sure I'm very clear about that. I'm making up these numbers as I go. So to get the cubed root, you're going to hit math and go to the cubed root button. And it is 2 to the 9th. Then I get out of my root and do times 3 to the negative 1. Again, 2.6 repeating, so that one is also equivalent. And then the last one, a little bit harder to type in, but I have, remember, 2 is x. I'm going to put 2's here, 3's here. So I have 2 to the 6th. To get a 4th root on the 83 calculator, you have to hit the 4 first. For my 84 calculator people, you hit math and go down to the one that says the nth root, and then you can plug that number into the root after. 3 to the 8th over 2 to the third, to the third, and 3 to the third. And I get that same number, 2.6 repeating. So that means that even if you didn't know how to do the exponent rules, it says that equivalent to. The only difference with this one versus the other ones I showed you is you have an x and a y. You just have to use 2 different numbers. Make sure you don't use the same number. And like my tip before, make sure you don't use 1 or 0. Because sometimes if you multiply by 1, it doesn't change something. If you add 0, it doesn't change it. And they can get a little bit icky and sticky. So just use different numbers. I always use 2 and 3. All right, inverse. These are usually gimme questions. So it says, given the inverse function, which function represents f of x? So this one's giving you the inverse and asks you to find the original. It's the exact same step-by-step to if you were finding the inverse given the original. You have to switch x and y, then solve for y. So in the inverse, I'm going to switch x and y. Remember, f of x just means y, so I'm going to make that an x. I'm going to make that a y. So I'm just going to rewrite it over here. It's x equals 2 over 3y plus 1 over 6. Now my second step is to solve for y. So I'm going to subtract the 1/6. So I get x minus 1/6. I can't combine them. They're not like terms. Equals 2 over 3y. Now to get rid of that 2/3, to get rid of it anytime you're solving an equation, you have to multiply by the reciprocal. So I'm going to have to multiply this by 3 over 2 because 2/3 times 3 over 2 cancel each other out. But what you do to one side, you do to the other. So I'm going to multiply this side by 3 over 2 as well. And make sure you multiply the whole side. Notice I already drew them in, but I'm going to be distributing that 3 over 2 through. So it's going to be 3 over 2x minus, when you're multiplying fractions, you multiply straight across. Or if you're not good at multiplying fractions together, you got your calculator here for you. you get math, enter that, you get minus 1/4. And that equals your f of x because it was your original function. So I'm going to look for that answer. Be very careful that you pick the right one. It is choice 3. Something else that might be helpful for this, especially to my more visual people, when you are doing an inverse, it's always going to be a reflection over this line, the line y equals x. So you could have done this graphically if this makes more sense to you by plugging in your original to your y1. Again, I'm here to show you a lot of different ways because there's always more ways. So 2/3 x plus 1/6. And I'm going to plug in choice 3 just so you can see what the reflection looks like. So we already know choice 3 is right, minus 1/4. So when you hit graph, you'll see that it reflects over that line. I'm actually going to put that line in my y3. So the green line is y equals x. See how it reflects perfectly over that green line? The red and the blue, they intersect right on that green line, and then they're perfectly spaced away from the green line. That's how you would know that that one is your inverse. I will just show you a wrong one so you know what that would look like. Choice 1 is wrong. So I'm just going to type in choice 1. And when you hit graph, they are definitely not reflecting. So see how the blue and the red are both actually on the bottom of the green line. They're not reflecting over the green line. So that's an example of a wrong answer. So if you wanted, you could just see that they reflect over like that. Boom. All right, 22, 23, 24, we are almost there. So number 22 is saying how many equations below are identities. So there are 3. We're going to have to check all 3 of them to see if they are identities. Identity just means that the left side is equal to the right side. So looking at the first bullet point, see how the left, there's not really much I can do with that. So that means I'm going to have to work on the right side and see if it equals the left side. So on the right side, this is going to stay as is. There's nothing I can do with that. I can't add like terms, nothing. But this side is being squared. Squared means write it twice. So 2xy times 2xy. When I multiply those together, I get 4x squared y squared. So what we end up with, actually, there's not much I can do here, is it's still going to be x squared minus y squared, but it's plus, because I'm bringing that over, 4x squared y squared. I can't combine any like terms at all, and that does not equal this side. So that right away is not an identity. All right, for the second one, no multiplying to be done here. Even though there's parentheses, it shows that they're being added. So all I can do is add like terms together. So I have an x, but there's no other x. I have a y, there's no other y. I have x squareds and y squareds. Those can't be combined. This is actually the answer. Nothing could be simplified in this one, which shows that this definitely is not equal to the left side. So that is also not an identity. All right, the last bullet point requires a little bit more work, but right now I know that definitely 3 of them are not equal and 2 of them can't be equal. So we're kind of debating between whether the last one works or doesn't between choices 1 and 4. Okay, so now I need to multiply this all together. So to see if this equals this, like I said, I'm going to have to multiply it all out. So my advice to you that we do in class is we always start by multiplying these 2 together first. I just think it's a little bit easier because it usually turns into a trinomial. So I'm not going to forget that that x minus y is there. I'll bring it down after. But when I distribute this out, I'm going to get an x to the third plus xy squared. Then I got minus x squared y, and this will be a minus y to the third. Now, if you can combine like terms, you would, but we can't, so that's what we have. So now I still have this there. I'm going to multiply that through. So I'm going to just bring this down, work smarter, not harder, and bring this in front of it, x minus y. So this is being multiplied to this now. So I'm going to have to distribute it all out. X times x to the third gets me x to the fourth. This is plus x squared y squared. This is minus x to the third y. This is minus xy to the third. Now I have more to multiply out. I have to multiply this negative y through. So negative y times x to the third is going to be minus x to the third y. This will be a minus xy to the third plus x squared y squared and plus y to the fourth. So we're seeing if it's equal to x to the fourth plus y to the fourth. So that means everything else in the middle would have to cancel. So let's try to find some like terms to see if they do. So I have a plus x squared y squared and a plus x squared y squared. Right away, that's going to get me 2x squared y squared, and they're not equal because those did not cancel. But I do want to check everything else just in case. Let's So when I try to do my negative x to the third y, negative x to the third y, those do not cancel either. That would get me a negative 2x to the third y. Everything's not really canceling out. This does not cancel with this either. I get negative 2xy to the third. So because those things are still going to be part of the answer as well as this and this, it is not equivalent, which means none of them are equivalent. Now, that was a lot of work. Here we go again with the shortcuts, you guys, the shortcuts, the checks. Even if you're like you're trying to get that 100 on this exam, or even just looking for mastery, you can use this as a check. Just like the last one where there were x and y's, you want to plug in a number for x and y. So I'm going to, again, use 2 for x, 3 for y. So if I use 2 for x and 3 for y, I'm not going to plug all of these in because I think we kind of get the idea. But the first one would be 2 and 3. For it to be an identity, it would have to match the left side where this is 2, 3, 2, and 3. So I'm saying x is 2, y is 3 again. So the left side would have to equal the right side for it to be an identity. Let's try plugging in the left side. So 2 squared plus 3 squared gets me 13. For it to be an identity, that would have to equal the right side. So on the right side, when I type this in, 2 squared minus 3 squared, just happened. Okay, plus this is 2 times 3, all in parentheses, squared. I get 139. Not an identity, that one's gone. And you would do the same thing for the other two choices to find out that none of them end up equal, so 0 of them are identities. All right, 2 more questions to go. Let's jump to number 23. All right, so number 23 is a focused directrix example. Remember what I told you guys in class? Please always draw a picture for these. So if the focus of a parabola is 0, 6 and the directrix is y equals 4, what is an equation for the parabola? So every time you have a focused directrix example, draw a picture, please, for me. So the focus is 0, 6, so I'm going to draw that in, 3, 4, 5, 6. Try to make it as neat as you can as well. I always label it focus, and I label it with what it is. The directrix is a line through y equals 4, so I'm going to put a line through. This is the directrix, which is at y equals 4. Now, when you have a focused directrix example, the vertex is very important. So is the formula for these. So the formula for focused directrix is something you're going to have to memorize, but it's plus or minus 1 over 4p times x minus h squared plus k. So hk, let me just add that somewhere. I'm running out of space. hk is the vertex, and p is the distance from the vertex to the focus, which is the same as the vertex to the directrix. Okay, that's why that vertex is right in the middle. It's going to be the same distance away from the focus as it is to the directrix. So your vertex is going to be halfway between the focus and the directrix. The point that's halfway between is right here, which is at 0, 5. So I just found every piece of information just by drawing that picture and finding the vertex. So the vertex is 0, 5, so that means h is 0, k is 5, and p is that distance between the two. So I'm going to zoom in really close to this. I'm talking about this distance and this distance. Those are going to be the same distances. The distance here is 1. The distance here is also 1. So that means that p is 1. Now, the other thing that you need to notice is whether it's positive or negative. For this one, or for any of them, your focus has to be inside of your parabola. So my parabola for this one is going to open upwards, which makes a happy face, which means it's going to be a positive parabola. If your picture had the directrix, then the vertex, then the focus this way, it would have to open downwards so that that focus is on the inside of the parabola. Remember, we talked about it in class. The parabola has to hug the focus. So because the focus was up for this one, it opens up. So that means I'm going to use the positive. So my equation is going to be y equals positive 1 over 4 times p. And remember, p is 1. So it's just 4 times 1, which is 4, times x minus h. So my h for this one was 0. So it's x minus 0. I'm just going to leave it as x. Bring down that squared from the formula. And then plus k, when k is 5, is going to be a plus 5. Now here's the fun part. None of the answers look like that. So we're going to have to either work with the equations in the choices or try to manipulate our answer to make it look like those. So what I'm noticing for those is two of them have the x squared. So these first two, like on top, choices 1 and 3, have a y squared. We do not have a y squared in our equation, so I'm going to get rid of those right away. The other two are solved for x squared, so we're going to have to do some math to solve this equation for x squared. So if I rewrite this, I'm just writing it again, x squared plus 5. I'm trying to solve it for x squared so that I can get it into the format that choices 2 and 4 are in. So if I'm solving for x squared, I'm going to subtract the 5 over. I can't actually subtract 5 from y, so I'm just going to write y minus 5 equals 1 over 4 x squared. And then to get rid of that 1/4, I'm going to have to multiply by the reciprocal, which is just multiplying by 4. Now when I multiply by 4 over here, those are going to cancel. But when I multiply by 4 on this whole side, I would normally be distributing through, but if you look at the answers, it doesn't want me to distribute through. You'll kind of see the answer in just a second. That x squared stays, and I'm going to leave it as 4 times y minus 5, which is choice 2. So again, normally we would distribute this through and get 4y minus 20. I didn't do that because of the way that the answers were formatted. So sometimes even just knowing how to do the question in a general way, there's still a little bit of extra math like solving for x squared that you have to do. It doesn't happen all the time, but when it does, you want to be ready for it. All right, last question. Here we go. So John and Margaret deposit $500 into a savings account for their son on his first birthday. They continue to make a deposit of $500 on the child's birth. I don't think I read that right. Hang on. John and Margaret deposit $500 into a savings account for their son on his first birthday. Oh, they continue to make a deposit of $500 on the child's birthday. So every birthday they're putting $500 in. With the last deposit being made on the child's 21st birthday. So they're doing it up through that 21st birthday. If the account pays 4% annual interest, which equation represents the amount of money in the account after the last deposit is made? This is a tricky example. The reason this is such a tricky example is because of the wording in it. They are not just adding $500 to the account each time. It's kind of going to be like, so the first birthday is $500. That's gaining interest. And then to that, they're going to add the next $500, which will also gain interest. Add another $500 to all of that interest already gained money. This is a sum example. Now, the pattern from term to term is a percentage, so this is a multiplying pattern. We have to use the geometric series formula. So the geometric series formula is given on the reference sheet. You can flip to that if you need to. I'm just going to copy it down. So it's SN, and you can kind of actually see that from this. That was a very helpful bit of information that they gave you guys right there. So it's SN equals A1 minus A1 times R to the N, A to the N over 1 minus R. And I'm actually going to double check because I don't know if that's the way I have you guys learn it in class or if it's how it's actually on here. It is times R to the N over 1 minus R. Times R to the N over 1 minus R. Perfect. Okay, now we need to know what everything means in this problem. So for this question, I have to figure out the first term. That one's not so bad. It's going to be 500 because that was the first deposit. So I'm going to just start plugging in the stuff that I know. 500 minus 500. Remember, those don't cancel because this A1 is being multiplied by something. So because of PEMDAS, those don't just turn into a 0. R is what? This is such a hard question. R is the rate, but it's the rate that is being like increased by each time. So when you are earning 4% interest, you are not taking 4% of the $500. That would be decreasing your amount in the account. You are keeping the original $500, which is going to be like multiplying it by 100% plus an additional 4%. So the rate that we actually have here is 1.04. So I'm going to repeat that because I know it's kind of tricky. If you were multiplying by 4%, like taking, I'll even show you, 500 times 4%, you get 20 bucks. That doesn't make any sense. This is gaining 4% interest, kind of like our growth and decay formula. You know how it's 1 plus R? That means it's going to have to be 1 plus that rate, which is 0.04, and that'll get you 1.04, which is where that came from. It's keeping that $500 and then earning 4%. Actually, this is a good way of explaining it. That growth and decay formula, that is growth. It grows by 4%, which makes the overall thing that you're multiplying by 1.04. Okay, so I have that on the bottom as well, 1 minus 1.04. I'm just plugging in the r again. And then the last thing we have to plug in for is n. Remember, n is the number of terms. Because they are doing this on every birthday until the child's 21st birthday, that means we're doing it for 21 years or 21 terms. So they're going to invest 21 times is the overall idea. Now, that is technically the answer, but it's not written like that, which just adds a little bit more to the difficulty of this question. So what I am noticing is its choices 2 or 4 because it has that 1 minus 1.04 on the bottom. Now, it is not going to be choice 4 because it doesn't have that 1.04. That one has to be wrong, which is how you can kind of process of elimination your way to choice 2. But the right mathematical way to get to choice 2 is, if you notice, they took out a GCF of 500. So if I take a GCF of 500 out of the top, it would put that 500 out in front. If you take 500 out of 500, it'll just leave you with a 1. If you divide this by 500, those 500s will cancel, and it'll leave you with that minus 1.04 to the 21 over 1 minus 1.04, and that will get you that choice 2. Again, the reason we knew this one was a series question was because we were finding the sum over the months. It was adding interest each year. So you had to account for that interest each year, and then all of those numbers at the end being added together for each of the years that it was deposited. So that gets you your final answer. Okay, that was a really fun questions number 13 through 24. I hope you join me again for the rest of the exam once we get to the showing the work part of these.